Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is total characters in string after transformations part 2. We have solved the part 1 yesterday and it was of medium level, but today's question, the part 2, is of hard level. And I would say this is actually very hard question, but I will try my best to make sure that after watching this video, after understanding the problem and the solution, this problem may seem a bit medium or easy for you. So in the problem, the given input is a string s. This string s we need to transform. There is an integer t which is representing how many times we can do the transformations, and there is another array which is nums, and this array is of size 26. Basically this array is representing 26 characters of lowercase alphabets. The output we need to give is the length of the transformed string. So we need to transform this string as t times, and after the transformation, the new string which we have got, we just need to return the length of the transformed string. Now let us try to understand what are the transformation rules. The first thing is we need to do the transformations t times. This t is given in the input, and we need to replace the characters of the string s. So these two inputs are basically the string s, the characters of the string s we need to replace t times. Now the next thing is, for each character, how are you going to replace it, or with what character are you going to replace it? This we will know from this particular rule. For any character in the string s, you need to replace it with the next nums of s of I minus a characters. Now this might seem a bit confusing, I will come back to it, but let us try to understand it with few examples. Let us say your current character in the string s is a. Now the question is, which character or how many characters are you going to replace this a with? So you need to say nums of a minus a. A minus a is going to be 0, so nums of 0. This nums is given in the input. So what you need to do is, you just need to minus a from your current character, and then you need to check at that index what is the value of nums, or what is the value at that index in nums. For example, if the current character is a and you got that nums of 0 is 3, it means you need to replace this a with the next 3 characters after a. So after a, the next 3 characters are b, c and d, right? Let us try to understand it with one more example. Let us say the current character is e. So again you have to replace the e with the next nums of s of I minus a characters. What is this? Nums of e minus a, right? So e minus a, e is the 5th character, a is the 1st character, so this will be 4, right? So you need to say what is the value of nums of 4. So let us say the nums of 4 is 2. It means you need to replace this e with the next 2 characters, which is f and g, right? So this is the transformation, or this is the replacement rules. One more thing which is very important to understand is the transformation is circular. It means that, let us say the current character is z, which is the last character in the English alphabet, and let us say you got that nums of z, that is whatever the value you got for this z, you will get this z at nums of 25, right? That's the index for z, and let us say the value at that particular index is 4. It means you have to replace this z with the next 4 characters, but there are no characters after z, right? And now you have to do it circular. So you have to replace the z with the next 4 characters, and in circular means you have to go a, b, then you have to go up to z, then it will come a, b again, right? So you have to replace this z with a, b, c, d, the next 4 characters. One more example is, let us say you have to replace this y, and nums of 24 is the index for y, is 3. Let us say it is 3. It means you have to replace this y with the next 3 characters, which is after y. So after y it is z, then again you have to go in circular and you have to say a and b. So you have to replace this y with z, a and b. Now why this problem is a bit hard? The reason is, this time it's not fixed for any character that how many characters you have to replace it with. It can be random, it can be any value. I won't say it is random, it is based on this nums array, right? But it is not fixed, and that is why it seems to be a bit hard. But let us try to make it easy. Let us try to understand the complete problem with an example. So let us say the s is a, b, c, y, y, t is 2, and this is your nums. Well, this is the string which you need to transform, and you need to transform it 2 times. The nums is 1, 1, 1, almost 25 times it is 1, and then you have 2. So it means that you have to replace a with 1 character after a, which is b. You have to replace b with c, c with d, and then up to y you have to replace it with z. For z, you have to replace it with the next 2 characters after z, which is a and b, right? Because it is 2, so you have to replace it with next 2 characters a and b. So for the first transformation, you will see that a, b, c, y, y will be transformed to b, c, d, z, z, because the nums of 0 is 1, which is for a, nums of 1 is 1, which is for b, nums of 2 is 1, which is for c, nums of 24 is 1, which is for y, right? So you have to replace it with next 1 character. Now again let me go back to this formula, nums of s of I minus a. It means that you have to, for this y you have to say nums of y minus a. Y is the 25th character, a is 1, first character, this will be 24. So index 24 in nums is representing the value for y, right? Now let us try to do the second transformation in the new string b, c, d, z, z. B, you have to replace it with next 1 character. For C it is 1, for D it is 1, for Z it is 2. right? So what you will say is B will be C, C will be D, D will be E, and Z will be AB, this Z will be AB. And this is your final string C, D, E, A, B, A, B. Total 7 characters, and that's the output. Let us see one more example. If the given string S is A, Z, B, K, and you have to do the transformation 1 times, and the nums is 2, 2, 2, let us say all the values are 2. It means each character will be replaced with the next 2 characters. So let us do it. This A will be replaced with BC, Z will be replaced with AB, B will be replaced with CD, and K will be replaced with LM. So the output is going to be 8 because we have 1, 2, 3, 4, 5, 6, 7, 8 characters in the final string. We just need to do the transformation 1 times, right? Now, let us try to see how can you solve this problem using brute force, that is no extra logic, just completely brute force. First of all, you will just store the frequency of each of the characters given in your string S. That is, you will know what are the characters present in your string and how many times. Then simply run a loop for t times because you have to do the transformation t times, right? And in that loop, in this particular loop, you will run another loop for 26 times. That's because this nums is of length 26, right? And you have total 26 characters, right? So what you will do is you will run a loop for 26 times, and for each character A, B, C up to Z, you will check that is it present in our string using the frequency array. In the frequency array or in the frequency map, you will know that if a character is present or not. If a character is present, then the frequency of that current character is going to be more than 0, right? If it is more than 0, let us do the processing. If it is not more than 0, skip it. So if it is more than 0, you will say run a loop for nums of I. Let us say A is present 2 times in your string and nums of 0, which is for A, is 3, right? So now you will run a loop for 3 times because you will have to replace this A with 3 characters, the next 3 characters, right? So you will have to increase the frequency of the next 3 characters B, C, D. That is, you have 1 B, you have 1 C, and you have 1 D now. So you will increase the frequency of next nums of I characters, right? Which is, let us say 3 right now. One more thing is, the next nums of I characters which you are going to increase the frequency for should be increased in a new frequency array. So you will create a new frequency array 0, 0 up to 26 times because you are creating a new string, right? So it will have a completely different frequency compared to what you had, right? So you will create a new frequency array every time in this transformation loop, and then you will run the loop for nums of I times, increase the frequency of next nums of I characters in a new frequency array, and then you will say that this new frequency array is your current frequency now. Again, you will go back to the loop if you have more transformations to do, and this time this new frequency array will be used to check that do you have the characters or not. And then after you have done this particular processing, you can just return the sum of your frequency array, and that is going to be the output, which is fine. This is going to run, or this is going to pass almost 90% of your test cases, but this is slow. This is brute force, right? So the time complexity is not the best what's required for this problem. So let me actually show you the solution of this problem using this brute force. This will give you a bit of idea about the problem and the solution approach. Now this is the solution approach using brute force. You create a frequency array. Initially it is 0. Then you note the frequency of each characters in your string S, and then you run a loop for t times, that is for t transformations, and then you create a new frequency array which is initially 0 for all the 26 characters. Now you run a loop for 26 times, and each time you see that do you have some count for that particular character. If the count is 0, it means the current character is not in your string. You can ignore this particular loop. You can just say continue. But if you have some count, you are going to say A is equal to nums of I. It means find the number which represents how many characters you have to replace this current character with. Run a loop for that many times for j in range 1 to k plus 1. Then for each next k characters, increase the frequency by count. So it will be new frequency I plus j mod 26, because this is circular, will be equal to new frequency I plus j mod 26 plus count. This count, let us say if it is A and you have A 2 times, then you have to replace this A with next 2 characters B, C. So you will replace both the A's with next 2 characters B and C, then B and C. So total you have 4 characters, right? And for each B and C, it will be 2 times. And that is why we are adding count in it, because count represents how many times you have A, right? Or the current character. Then after you come out of this loop, you can just say frequency is equal to the new frequency array which you created. And then you run the same process for t times. And then when you come out of the loop, just return the sum of the frequency. And the question asks that you have to return the answer, because the answer can be very large. You have to return it with the modulo of 10 to the power 9 plus 7. So we are creating a variable mod 10 to the power 9 plus 7. And then you return the sum of the frequency mod using this mod variable. So that's a good solution, and you will see that it's almost passing 529 test cases. But yes, it is a time limit exceeded issue. So let us see an optimized approach. How can we solve it in optimal time? Now the optimized approach is using matrix multiplication. First of all, what you will do is you will create a 2-dimensional array of 1 by 26. It means it will have 1 row and 26 columns. It will look something like this. Now this array will be used to store the initial count of the characters in S. Now this is very similar to the brute force. We are storing the frequency of each character. But this time we are doing it in a 2-dimensional array because we will utilize this matrix multiplication property, and you will see how. So we create an array A, and this is going to store the frequency or the count of the characters in the string S, and then you create another array B which is 26 by 26. 26 rows. Each row is for each character A, B, C up to Z, right? and for each row there is a dedicated column of 26 length, and this 26 is representing what each character will lead us to. It means that if it is for A, and let us say nums of 0 is 3, right? So this array, this particular column is for A is going to store 1 1 1 for B, C and D. That is, A can lead us to make B, C and D. So I will show you how this array will look like. For now you can just understand it in this way, that the rows are representing each character and the columns are representing for each character what each character will lead us to. A will lead us to B, C, D. Maybe C can lead us to D, E, F, G if the value of nums of 2 is 4, right? And then you will create a function. Now this is a very simple function which you will create, which can multiply two matrices. You have to do matrix multiplication. So let me show you what are the rules for matrix multiplication. The matrix multiplication rules. Let us say you have to multiply two matrices A and B. Then the rule is the size of A should be A by B, A rows, B columns. Then the size of B should be B by C, B rows and C columns. So basically if you are multiplying A with B, the number of columns in A should be equal to the number of rows in B, A, B, B, C, and the resulting array or the resulting matrix is A by C, right? A rows and C columns. For example, if there is a matrix of 1 row and 26 columns multiplied by 26 rows, 26 columns, then the result will be 1 row and 26 columns. If it is of 26 by 26 multiplied by 26 by 26, it will be 26 rows, 26 columns. Now let us try to understand this optimized approach using this example. I have modified the example number 1. What I have did is, I have set S is equal to A, B, C, Y, Y. The number of times we need to do the transformation is 11. And let us say the nums is 2, 3, 4, then 1, 2. This 2 means that for A, you will replace it with next two characters B and C. This 3 means that for B, you will replace it with next three characters C, D and E. This 4 means that you will replace C with next 4 characters D, E, F and G. So similarly, this is for Y, this is for Z, right? So this is your nums array. Now the output in this case is going to be 52. It is very hard to dry run the process because the matrices are of large, very large size, 26 by 26, right? I will show you how this will work with small example. But for now, let me show you how the array A and how the array B will look like. This array A is basically the array which is going to store the initial count of the characters in S. And this array B is the 26 by 26 matrix or array, which is 26 rows for each character, 26 columns for what each character will lead us to. So let us understand this. This A is going to be equal to 1, 1, 1, 2, 0. 1A, 1B, 1C, then you have 2Y and 0 number of Z. 1A, 1B, 1C, 2Y, right? So basically this is the count and this will be a two-dimensional array of size 1 by 26. Alright. Next is create a two-dimensional array B of size 26 rows, 26 columns. The rows are representing each character A, B, C up to Y and Z. And for each character, there is another 26 length array assigned, which is basically the columns. Now, for each character, we are setting a value as 0 or 1. Right? It will be 1 if a particular character will lead us to that character. So you will see that A will lead us to B and C, right? Because it will lead us to the next two characters. So what we are setting is for B and for C. This is A, this is B, this is C, right? So for B and C, we are setting it as 1. For B, the value is 3, right? So it will lead us to the next three characters C, D and E. So for B, it is C, D and E, which is 1, right? So it is very simple to understand, right? For C, it is not A, not B, not C, but D, E, F, G, which are the 4 characters this C is going to lead us to, because nums of 2 is 4, which is for C. So we have created this particular matrix. Now the simple formula is, if this is your matrix, what you will do is, the value of T is 11, right? So what you are going to do, you are just going to say B is to power 11. You have to multiply this B 11 times, and then you will have a matrix which is of size 26 by 26, right? The size of the matrix is not going to change because you will see that 26 by 26 multiplied by 26 by 26 is the same size, right? So you have to say B is to power 11, and then you will have to multiply this resulting matrix with A. So it will be A multiplied by B is to power 11, right? And now why this formula will work, I will show you this with small example. But for now, let us say this formula works. So how this will look like? This A is 1 by 26, this B is 26 by 26. So the result is 1 by 26 matrix, right? So you have a matrix, or you have a two-dimensional array which is having just one row and it is having 26 data. You will take the sum of this, take the mod of this with 10 is to power 9 plus 7, and this is going to be the output. Now how this output will work, how this formula is correct, I will show you. So let us try to say that you just have 3 characters A, B and C. Okay, let me show you an example. Let us say the S is ABC. You have to do the transformation 4 times and the nums is 2, 2 and 2. And let us assume that the characters in English alphabets are just A, B and C. Now this will be easy to demonstrate. So the nums is 2, 2, 2. It means that A will lead us to the next two characters BC, B will lead us to the next two characters CA, and C will lead us to the next two characters AB, right? Let us say this is the example. Now, if you will normally do it, what will happen? This A will be BC, B will be CA, C will be AB. So you have 6 characters after one transformation. Now each character will again double, right? So what will happen? B will be 2 characters, C will be 2 characters, C will be 2 characters, A will be 2, A will be 2, and B will be 2. So you have 12 characters. Then you will have 24 characters, and then you will have 48 characters after 4 transformations, right? Now let us do the same thing using the formula which we have just saw, that you have to say A multiplied by B is to power T. Now we will come to the A array. We will come to this particular 2D array of size 1 by 26. For now, let us focus on the array B. We have to say B is to power 4, right? So what we are going to do is, this is B, right? You have A can be converted to BC, B can be converted to AC, C can be converted to AB. You will multiply this matrix with this matrix. After matrix multiplication, the output is going to be 2, 1, 1, 1, 2, 1, 1, 1, 2. This is your new matrix. Now this is B square, right? You will have to find B is to power 4. So you can say B square multiplied by B square, right? So it will be B is to power 4. So what you can do is, you can just do the matrix multiplication again. You will multiply this with this again, and this time it will be 655, 565, and 556. Now comes A, right? Your A is a two-dimensional array 1, 1, 1. Why? Because this is the count of the number of characters in your string. So you have 1A, 1B, 1C. So 1, 1, 1. Now you will multiply this with this. You will find that this is equal to 16, 16, 16, right? A 2D array of size 1 by 3. Because right now we are just assuming that there are 3 characters, right? So you can just say 16 plus 16 plus 16, and the output is 48, and that's what we have got. And that is why I am saying this formula will stand. This formula is correct. A multiplied by B is to power T. Now the main question is, how can you optimally do this process? What is the most optimal way to do this process? I will show you that. Let us say the T is 11, and you have a matrix M which you have to multiply, like M is to power 11. T is 11. You will say M multiplied by M. Right now the M is M. It is not squared or powered any times. So M is to power 1. So this will be M square. Then you will call the function again. We will create a function for this. Then you will call a function again, and this time with half of 11, which is 5. And this time the value will be M square. So M square multiplied by M square is M is to power 4. Now again you will do the same process. Call another function, this time with 2. This is the half of 5. So M is to power 4 multiplied by M is to power 4, which is M is to power 8. And then you will call it again with the half of 2, which is 1. And if it is 1, you will return back. You will not do anything. Now when you will return back, then if it is even number, then you will not do anything. You will again return back M is to power 8. So you have M is to power 8 return at power equal to 5. But if it is odd, you will multiply this with the current number you have, or the current matrix you have. So M is to power 8 multiplied by M is to power 2 is M is to power 10. Again you will return back, this time with M is to power 10. And now again this is an odd number. So you will say M is to power 10 multiplied by the current matrix, which is M. So this is M, which is M is to power 11. You have to do this just for 1, 2, 3 and 4. Just 1, 2, 3, 4 function calls instead of doing it 11 times. So this is going to be really optimal, and this is basically log of 11, that is log of t, that is the time complexity for this, instead of O of t, right? So this is the complete explanation of how we can solve this particular problem, and I know this is a bit hard to understand. This is a very complex problem to solve, but you have to just practice this thing. You have to understand the examples with dry runs. So if you have not understood few parts, just make sure that you rewatch that part, or you can just directly add something in the comment box and I will provide you the approach or the solution for your problems. But now let me show you how can you solve this using Python in the code editor. So let me go back to the code editor, and this time let me show you what is the actual code for this. So first of all, you will create this mod variable, which is 10 to the power 9 plus 7. Then create a size variable, which is 26. This will be useful in many places. Now create the array A, which is of size 1 by 26. Then you create the count of each character in your S, right? So this is counter of S dot items. Then we are just creating the count of each character in our two-dimensional array A. Then you create an array B, which is of 26 by 26. Initially all are 0. Then run a loop for 26 times, and then for each character find out what is the number of shift or what is the next number of characters you have to replace it with. Run a loop for that many times, and then just put 1 for each character which a particular character will be converted to. Now you have two functions, def multiply. This is basically a multiplication function which will multiply two matrices, and then there is a matrix power, which is given a matrix, raise it to the power, whatever power is given. So this power will be t, the number of times you have to do the transformations. So we will understand both of these functions. Let us see what we have to do. Let us say bt is equal to matrix power b comma t. It means you have to find what is b is to power t, right? So for that, if the power is 1, you need to return the matrix directly, and if it is not 1, then you will call matrix power again, but this time you will multiply the matrices. So m will become m square will become m is to power 4, and then you will have to call this matrix power with half of the power, right? And whatever is returned to you, finally what you will have to return is, you will have to multiply your matrix with current number or current matrix power if the power is mod 2 is having some value, that is if the power is odd. And if it is not odd, you can directly return whatever the matrix you have right now. Once the matrix multiplication is done, the final thing is what you will have to do is, you will have to say a multiplied by b is to power t, right? So you will say multiply the matrix a with bt, and whatever you have got, just find the sum of that array, mod it with the mod variable, and that is going to be the complete solution for this particular problem. So you can just submit this particular solution, and this is going to be the complete solution for this particular problem. So yes, you can see that the runtime is good, the runtime is fairly good, the memory used is good as well. So we have solved this particular problem. Let me show you the complete code. So this is the complete code, right? I'm scrolling it so that you can just pause the video and see the code. So that's it for this video, guys. I know that this is a bit hard to understand, but I hope that a lot of things after watching this video are cleared about this problem and the solution approach as well. And if it did, then make sure that you hit that like button. And if you're not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. Thank you for watching this video, guys.